Everyone, and welcome to an overview of Lesson 3.5, Linear Equations in Three Dimensions. We're going to start off by talking about the three-dimensional coordinate system and how to graph a point in three dimensions. Now, we live in three dimensions. Everything around us is three-dimensional. So when we want to represent something in three dimensions, we have to tell somebody how far left or right to go, how far up or down to go, then how far back or forward to go. So our three-dimensional coordinate system actually is represented by three axes. Okay, we have the normal x-axis, we have the normal y-axis, but then we add in the z-axis. Okay, so the x and y-axis are how we normally are used to seeing this, but the z-axis tells us how far back or forward to go. Now, when you draw your coordinate plane for this, you would have the vertical axis, the horizontal axis, and then we add in this one going this way. A lot of times in the book, you'll see it turned so that this is your positive y, this is your positive x, and this is your positive z. It's up to you how you want to label them, but I am assuming that any place that you put the x is going to be your positive area. Any place you put your z is your positive, and y is your positive. You can move these letters around as you desire. I'm putting them here just to keep it kind of more conventional where you have the positive x and the positive y. That's where you normally would have them. Now, this is the one type of graphing that I'm not going to ask you to do on graph paper because it's actually much harder. But because of that, what we need to do is we need to draw out where we're going with our point. So for point A, this is an ordered triple because we have our x, our y, and our z, and it is in alphabetical order. So you have to go 2 units on your x, so I'm going to go 2 units on my x. Then I need to go 3 units on my y. So it's 1, 2, 3 steps up. And I do 3 little dashes to show 3 steps up. And then -2 on my z. So I have to go back 2. Now this is z positive here. So I'm going to draw a line parallel to my z-axis. And I'm just going to go 2 steps back and put a dot. And that's point A. Now, because all of this is estimating, we're all going to get point A in a slightly different position. Some of you might have it a little further over here. Some of you might have it a little further over here. If you put your axes in a different position, well, it's going to be different. But as long as you label it and you show carefully how many steps you take in each direction, it's going to be okay. So that was point A. Let me show you another example for point B. Point B is -1 on your x, 1 on your y, and 2 on your z. So on my x, I'm going to go -1. I'm going to go 1 up on my y, and +2 on my z. So that's headed in this direction. So 1, 2 on my z, and there it is for point B. Okay. Now the last one I needed was point C. X is -3, y is -3, and 0 on my z. So I'm going to go -3. So 1, 2, 3. Y is -3. So 1, 2, 3. That's parallel to the y-axis. And then there's nothing on the z. So I'm just going to stay right here for point C. Okay? So that's how we graph points. Okay, so you're mapping out which way you're going with little dotted lines. As you go off of the axes, you want to make sure that if I'm doing a y-coordinate, those y-coordinate dotted lines are going to be parallel to the y-axis. So notice this vertical green line is parallel, the vertical red line is parallel, the vertical blue line is parallel to the y-axis. And same thing with my z-coordinates. They're going to be parallel to the z-axis. Okay, so that's what we're careful about when we're graphing points in three dimensions. Now, what if I wanted to graph a linear equation in three dimensions? So instead of doing just points, what if I wanted to do a linear equation? Linear equations, we use the intercepts to graph them. Okay, and they look like regular linear equations, but they're going to have three variables involved. Okay, so my linear equation that I'm going to be graphing is 3x plus 4y plus 2z equals 12. And we're going to use the intercepts. Let me just draw my coordinate plane again. Oops, I missed the intersection. Let's just move this axis a little. Okay, there we go. Okay, so to find my intercepts for my x, all I do is I cover up these and I get the one-step equation, 3x equals 12. So I'm going to divide to get x alone and find out that x is 4. Now to find y, okay, I'm going to cover up the x and the z, and I get 4y equals 12. So I divide to get y alone, and y is 3. And then for z, I'm going to do the same thing. I cover these up. 2z is 12. So divide that, and you get z is 6. Okay, so on my coordinate plane, again, I'm going to label x positive, y positive, and z positive, just to give anyone looking at this an indication of which direction is positive for each axis and which axis is each one. Now, for x equals 4, I'm just going to go out 1, 2, 3, 4 tick marks on my x. I'm going to put a dot. Y equals 3, I'm going to go up 1, 2, 3 on my y-axis and put a dot. Z equals 6, I'm going to go 1, 2, 3, 4, 5, 6 on my z-axis and put a dot. And I'm going to connect them into a triangle. And that's how you graph a linear equation in 3 dimensions. It looks like a triangle. It's actually going to be a 3-dimensional plane that's kind of angled. Very hard to show in 2 dimensions, which is why we do it in this manner. We show our intercepts, x is 4, y is 3, z is 6. So we show those intercepts, we show it on our coordinate plane, but it's going to kind of look like a triangle. Okay, for this lesson, we had one more thing to talk about, and I'm going to do that in a separate video. It is a word problem. So don't miss that other video. It's the last thing in the lesson, and I'll see you there.